Hi, and welcome to 6.3 example 1. Here we want to graph this system of linear inequalities and determine a solution. So in this case we have two linear inequalities that we want to graph, and we want to find out where their two kind of shaded in areas will overlap. Okay, so what I'm going to do first is I'm just going to label this one as 1, this one as 2. So let's just deal with 1 first. So for 1 we have 2y minus 1x is greater than or equal to. So greater than or equal to tells us we can use a solid line. Right? And then it's real numbers, which tells us that we're allowed to shade, right? And that which is also what we call continuous for our solution. So we can use a solid line and it's a continuous or a shaded in area. Okay, so first thing we do is graph the line of 2y minus 1x is equal to 4. Okay, then we worry about the greater than or equal to after. So 2y minus 1x equals 4. Okay, we could do this using y equals mx plus b. So we'll just do this in a couple steps here. We'll add the 1x to the other side, and divide everything by 2. So we get y equals 1/2 x plus 4 divided by 2, which is 2. Okay, so we want to graph that. So we go over, we label our axes, x and y. Just looking at the question in general, we're going to have kind of normal numbers to work with here. Nothing big, nothing too small. So we label our axes, just 1 per box. Okay, something like that. Okay, so to put this on, we have a y-intercept. Right, this is our y-intercept of 2. We've got a slope of 1/2, so we go over, we put a y-intercept there at 2, and the slope of 1/2 means we go up 1 over 2, find a point, up 1 over 2, find another point, up 1 over 2, find another point, and we could do that as many as we want. And then we will graph a solid line through those points. Okay, remember this solid line will be able to extend fully in all directions because we're dealing with real numbers. Okay, it looks like that. And we'll put arrows on the end of that, just meaning it continues. Okay, so that's our line for that. So maybe I'll mark that with a 1, indicating that that's my number 1. Maybe I'll put that up here too. So that's the first inequality, but we haven't dealt with the inequality part yet. We just dealt with the line. So we need to decide above or below the line to shade. Okay, so to deal with that, we could use a test point. Right, so take, let's say 0, 0 as our test point. Okay, maybe we could shorten that up to be a TP. Test point, 0 and 0. So we sub into our original equation, right, which was 2y minus 1x is greater than or equal to 4. So it's 2 times by 0, we take away 1 times by 0. Is that greater than or equal to 4? So 0 greater than or equal to 4? No, it isn't. So that means our solution set for this line isn't below, it's above that line. Okay, so I'm just going to mark that with some arrows. Again, coloring in with pencil crayons would be really good, but it can get pretty messy if we don't do a good job with it. So I'm just going to use arrows on bigger questions like this. Okay, so that's our first one. Now we have to graph number 2. So I'm going to just erase some of this here. So for number 2, right, our equation is 3x greater than y. So just look, I'm just going to mark this up in the top corner here. So the greater than indicates that our line isn't part of our solution set. So for that we need to use a dashed line. And again, with the real numbers, that means we can shade because it's continuous. Okay, looking at this one here, we want to graph the line of 3x equals y. Right, rearranging that, that's actually y equals 3x. Looks more like the way we like to graph it. Okay, this looks a little bit funny, but recognize, right, this is actually just a plus 0 here. So we have y-intercept of 0, and we have a slope, which is the 3. Okay, so we have a slope of 3 and a y-intercept of 0. So we go over to our graph, we mark our y-intercept at 0, and the slope of 3, right, is actually the same as 3 over 1. So we go up 3 over 1, we get a point, up 3 over 1, we get another one, up 3 over 1, we get another one. Okay, and then we're going to put our ruler on there. But before we draw that line, remember that we need to use a dashed line for this. So we go through that with a dashed line again because it's just a greater than sign, it's not greater than or equal to. Okay, and something like that. Okay, so we've got our line. I'm going to quickly label that as number 2. Now we need to figure out which side of that line is our solution set. Is it the left side or is it the right side? So to do that, we need to, again, use a test point, but, our test point here of 0, 0, we can't use because it's actually on our line. So that doesn't help us. We need to pick a different point. So maybe for a test point, I don't know, let's pick a point here of 2, 2. Right, so I can take a test point of 2, 2. So if this equation works out, that means that side of the line is our solution set. If it doesn't, it means the other side of the line is. So we plug into our original equation, which is that 3x greater than y. So we sub into there, it's 3 times by 2. Is that greater than or equal to 2? Is 6 greater than or equal to 2? Well, yes, it is. So that means the side of the line with this test point here is our solution set for that. Right, so it's everything on this side of that line. Okay, and now the last step here is to figure out where do our solution sets overlap. Okay, so where do our solution sets overlap? Well, we look at where these arrows are. So the green arrows are pointing into here. Red arrows are pointing into here as well. This part in here is our actual solution set. Right, so this is the part where we would shade in the darkest, or if we're just using arrows, the part that we would shade in. So that is our solution set, that yellow highlighted area there. And then this question says to determine a solution, so it's just asking for one possible solution. So we could pick any point within this highlighted area. So for example, I don't know, this point right here, right, that point is 5, 6. Right, so we could just say 5, 6.